Okay, so in this video, we're going to talk about our new unit called stoichiometry. Okay, now this one's almost exactly like the one that we did for moles, but we have, remember when we do like the steps, there's going to be a couple more steps that we add to it, and we have to look at a balanced equation and all this. To know how to pronounce this, it's called stoichiometry, and I'm going to write how you say it. You need to write this above your paper because that's how I'm going to know that you watched the video and you didn't just copy from somebody. So, it's pronounced stoi, and then think of ki, e, and tree. So stoichiometry. Okay, and so that's what this unit will be about. What is it? It uses molar ratios, so we're going to be comparing moles of something from a balanced equation to predict the amounts of a product a reaction will produce. It can also tell you how much of each reactant is needed for a desired amount of product. Now, so this is very important to tell us if I need 35 grams of oxygen in order to react with 50 grams of nitrogen, I need to know the exact amount I need so we don't waste it. Wasting is the worst thing that you can do in chemistry, so we try to get the exact amounts. Now this is very, very simple. This is a very, very simple version of what it's like, but you still need to show me the work because it's about how we're doing the problem, not necessarily how easy the problem is. So make sure you work out all of these problems with me. So here, I have an equation here. It says to make a turkey sandwich, I need 2 slices of bread, 1 slice of turkey, and that gives me 1 turkey sandwich. So I'm going to write an equation. My equation will be 2 breads, so I'm going to abbreviate bread with a B, plus 1 turkey, T, and that's going to give me 1 sandwich, okay, 1 turkey sandwich. So there goes my formula. So when I start solving them, that's the abbreviations I'm going to be using. So first problem, if you have 10 slices of bread and excess turkey, how many turkey sandwiches can you make? Now, here's a new word that we are learning now, excess turkey. Excess is another word for saying I have more than I need. Okay, that means I have a whole bunch of them. So what can I do? I can ignore that. I can ignore excess turkey. So we're going to set up our problem. What's the first number I should put? Is the 10 slices of bread. I'm going to abbreviate it 10B. And we're going to set up a problem like we did for moles using dimensional analysis. Remember, nothing goes in this box right here. And since I have bread right here, then bread is going to go at the bottom. And they want to know how many, here goes, how many sandwiches, how many turkey sandwiches. So I'm going to put an S at the top. Here I have an equation. Now I need to figure out what numbers go for B and S. I'm going to look at my balanced equation right here. Here's my balanced equation. And I'm going to look, bread has a 2 in front. That's the 2 for the coefficient, so I'm going to put a 2 there. And a sandwich has 1 right there. Sandwich has 1, so I'm going to put a 1 there. Don't forget to cancel your units, so bread gets canceled out. Bread gets canceled out. And now I'm left with some sandwiches. So 10 times 1 divided by 2, and I will get 5 sandwiches. I think that's how you spell it. 5 sandwiches. So, easy. You could have done that without using dimensional analysis, I know, but when the problems get more difficult, you're going to have to use it. Let's try number 2. Number 2. If you have 6 slices of turkey and excess bread, how many sandwiches can you make? What should I ignore in this problem? You should always ignore the excess bread because I have more than I need. So let's begin. I have 6 turkeys. Put a T there. And that's the number I'm going to start with. So let's set up a little problem. I have turkey right here, so I'm going to put turkey at the bottom. And they want to know how many sandwiches. Same kind of problem from before, so I'll put an S. Where do I get those numbers from? The balanced equation. Same place I got the other numbers from. Turkey has a 1 with it. Sandwich has a 1 with it. I'm done. 6 times, let's cross out our units. Turkey, turkey. So my final answer will be in sandwiches. So 6 times 1 divided by 1 gives me 6 sandwiches. Okay. Let's move on to our next problem. Let me write back our equation that we had before. If you want to make 15 turkey sandwiches, how many slices of bread should you start with? So here I'm starting with 15 sandwiches. So let's start with 15 sandwiches in my problem. Okay, I'm going to put my lines here. I have sandwiches at the top, so I'm going to put sandwiches at the bottom. In this problem, it says how many slices of bread. So bread goes on top. I have 1 sandwich in my balanced equation, 1 sandwich right here, and 2 breads for every 2 breads. Sandwiches will cancel out this time, and so my final unit will be in bread. So if you multiply it, I'll have 30 breads, or pieces of bread. Number 4. If you have 14 slices of bread and 5 slices of turkey, how many turkey sandwiches can you make? So this one, there are 2 separate numbers. 14 breads, 5 slices of turkey. We're going to run into these type of problems later on in this unit. You need to set up 2 separate equations and solve 2 separate problems. So let's set up the first one. 14 breads. And they want me to go to, they want both of them to go to sandwiches. So I have bread there, bread here. And I'm going to sandwiches. Where do I get these numbers from? The balanced equation. So I'm going to look all the way to the top. Balanced equation up there. Okay, so 1 sandwich, 2 pieces of bread. Bread cancels out, bread cancels out. I'm left with sandwich. So, if I put that in the calculator, 14 times 1 divided by 2, I will get 7 sandwiches. Now, we're going to set up a whole nother problem over here. 5 slices of turkey. I'm going to have turkey at the bottom, sandwiches on top. Look back up here. Balanced equation. 1 and 1. Plug that in, I'm going to get 5 sandwiches. So I have 2 numbers here. It says if you have this and this, how many sandwiches can I make? Well, I can either make 7 or 5. You should always, always, always pick the smaller number. I only have enough ingredients to make 5 sandwiches. If I had more turkey, I could make 7 with the bread I have, but I don't have it. I don't have enough. So I can only make the smallest amount, which is only 5 sandwiches in this problem. Okay? All right. So now let's look at an actual, here goes a formula that we have. N2, which is nitrogen, so nitrogen here, is going to react with hydrogen, and I'm going to get NH3. We're going to call NH3 ammonia. Okay, that's what it's called, ammonia. And so, what is the coefficient in front of nitrogen? What number goes right here? Remember, if I don't give you a number, you can always assume that the number is 1. Okay? So just think of it as a 1 there. So 1N2 plus 3H2 gives me yields 2 NH3s. So this reaction is telling you that when one molecule of nitrogen, because there's a 1 in the front, the 1 in the coefficient right here, combines with 3 molecules of hydrogen, right here, 2 molecules of ammonia are made. So if I had a bag and I filled it with one molecule of nitrogen, pretend this is nitrogen, I'll get a different color for hydrogen. So here goes hydrogen, 1, 2, 3. There's 3 molecules of hydrogen, 1, 2, 3. If I put that in a bag, what would happen? Well, it tells me, if I put that in a bag, what would happen is I would have a nitrogen, 1, 2, 3, 1, 2, 3. I would get 2, 1, 2 NH3s. Okay? So this is the formula that they're giving me, okay? So let's keep reading. The number of molecules also refers to the number of moles. So you can compare the number of moles of a compound that goes in with the number of moles of a compound that is produced. Okay? So according to the reaction above, it's the same numbers. 1 mole of nitrogen, so I'm just making it a lot bigger. 1 mole of nitrogen combines with 3 moles of hydrogen to produce 2 moles of ammonia. I got all those numbers, again, from the balanced equation from above. So, why do we need to know that? Is because now we're going to be using a thing called mole-to-mole ratios, or molar ratios. Off to the side, I would like you to put mole to mole, because that's how I'm going to be referring to this. So what it does is it uses the coefficients in a balanced equation, ratios comparing number of moles of one substance to another in a chemical reaction. This problem right here on the board is not on your paper. So just look and observe, okay? You're just looking and listening. So here I have 2 moles of AlBr3 reacts with 3 moles of Cl2. And if I put those in a bag, what am I going to get? I'm going to get 2 moles of AlCl3 and 3 moles of Br2. Okay? And so if I'm going to be comparing them, then I'm going to say, okay, so let's compare, let's just pick 2. Let's say I want to pick this one and this one. I want to compare those 2. So the first one, so let's look at this one. This has 2 moles of AlBr3, and I'm going to divide that by this one. And let's say this one is also 2 moles of AlCl3. Where'd I get those numbers, the 2's from? From the balanced equation. It's already balanced. Perfect. All right, let's pick 2 different ones. Let's pick okay, let's pick this one and this one. I want to compare these 2. Now you can compare some on the same side. That's fine. That's not a big deal. So let's start with this one. I'm going to say, I don't know, I have 2 moles of AlCl3. And then at the bottom, I'm going to have 3 moles of Br2. Okay? I got those numbers from the balanced equation. So let's look at a problem that's actually on your paper. This one. This is your first problem on your paper. It says, we're going to write the mole-to-mole calculations. Nitrogen and hydrogen react to form ammonia. Okay? Nitrogen, hydrogen, ammonia. The balanced equation for this reaction is, there it is. What are the 3 molar ratios for the above reaction? What does that mean? When they want 3 mole ratios, they basically want you to pick 3 different combinations. Okay? Just like I did before where I picked 2 combinations, they want to have 3 different kinds. So here, I'll change colors between each of them. So let's say I want to do one combination is N2 and H2. Okay, I wanna compare those first. So what number is in front of N2? 1. Don't forget, there's a 1 if there's no number. So I have 1 mole of N2, and that's going to be over here, 3 moles of H2. And so that's a first ratio. So it's 1 to 3. 1 mole of nitrogen, 3 moles of hydrogen in this formula. Okay? Let's pick another combination. Let's do nitrogen again, but instead of hydrogen, let's pick NH3. So we'll start with nitrogen. Again, I still have 1 mole of N2. And I have 2 moles of NH3. So what does that mean? In this equation, it'll be a 1 mole of N2 to 2 moles of NH3 ratio. Okay, I'm comparing them. Last set, we haven't done this set yet, where we have H2 comparing with NH3. So I'm going to have 3 moles of H2, and I'm comparing that to 2 moles of NH3. Okay, and there they are. There goes the 3 mole ratios. All of them are different. All of them have a unique thing about them. Okay, so let's look at this one. How many moles of ammonia are produced when 0.60 moles of nitrogen reacts with excess hydrogen? Like I said before, there goes our word with excess hydrogen. We can ignore that in our problem. Okay, excess just means I have more than I need. I have more than enough. So let's start. How many moles of ammonia are produced when 0.6 moles of nitrogen reacts? So start with my first number. 0.60 moles of N2. In this unit, you're going to need to write the unit, which is moles, and the compound, which is N2. You have to. If you don't write both of these, you're going to get them wrong because we're going to be comparing different elements. So I'm going to put a little box here. Now it says how many moles of ammonia. So that's what they want to know. Moles of ammonia. So if I have moles of nitrogen here, what unit do you think goes down here? The exact same. Moles of nitrogen. They're always the same. This problem wants me to get moles of ammonia, so I'm going to put that on top. Moles of NH3. Now, where am I going to get these two numbers from, though? Because I need to put numbers there. I'm going to get it from the balanced equation, the equation at the top. What number's in front of nitrogen? 1. Don't forget, there's a 1 right there. What number is in front of NH3? 2. Okay? Now, what unit can I cancel out? I have moles of nitrogen here, moles of nitrogen here. So my final answer will be in moles of NH3. Multiply the top, divide by 1, and you will get 1.2 moles of NH3. Okay? Let's move on to our next problem. Here goes a new formula. 4Al plus 3 oxygens will yield 2 aluminum oxides. So what are the 6 molar ratios for the reaction above? Now, we've done 3 before, so we're a little confused on how to do 6. So why don't I start by doing the 3 that we know how to do. So let's say I want to compare Al and oxygen. So I'm going to do that one first. So 4 moles of Al. And what is it? 3 moles of oxygen. Okay, great, done. That's the first one. Next one. Let's do Al and Al2O3. So I have 4 moles of Al, and I have 2 moles of Al2O3. Okay. And I'm missing 1, which is oxygen being compared with Al2O3. So I have 3 moles of O2 being compared with 2 moles of Al2O3. Okay. Now here are the 3 that we've done before, but it's asking for 6. The way I can get 6 is that I can reverse each of these. So here I have 4 moles of Al and 3 moles of oxygen. What if I flipped it and I said 3 moles of oxygen over 4 moles of aluminum? That also counts as 1. There, now I have 4. I can also flip the next one. 2 moles of Al2O3, and I can divide that by 4 moles of Al. Again, so all I'm doing is I'm just flipping it. And that's giving me a whole new set. 2 moles of Al2O3 over 3 moles of oxygen. Okay? So there, now we have 6. Read the problem. How many moles of aluminum are needed to form 3.7 moles of aluminum oxide? What number should I start with? Always start with the number they give me right here. 3.7 moles of Al2O3. Before you even start and even look at to see what you want to solve for, you should at least get this far. You should know even what unit goes down here at the bottom. I have moles of Al2O3 at top, so I have to put it down here as well. Moles of Al2O3 right here. It wants me to go, if you read the problem, it says how many moles of aluminum. So they want me to go to moles right here. It says it right here in the problem. Moles of aluminum. Moles of Al. Where do I get those numbers from? The balanced equation. I'm going to look all the way back to my balanced equation. What number is in front of Al2O3? A 2. So I'm going to put a 2 there. What number is in front of aluminum? 4. So I'm going to put a 4 there. Let's cancel out our units. I have mole of Al2O3 right there, and a mole of Al2O3 right there. So my final answer will be in moles of aluminum. Multiply the top 2 numbers, divide by 2, and I will get, you should get 7.4 moles of aluminum. And there you go. And there's your reaction. So, if I had 3.7 moles of aluminum oxide in a bag, and I'm like, how did I get that? I needed 7.4 moles of aluminum to get there. Okay. Start working this problem now. This one's a little bit longer, but it's fine. If 2.4 moles of sodium hydroxide is reacted with an excess of H3PO4, there goes our word again, an excess of H3PO4. I can ignore that. How many moles of sodium phosphate will be produced? So start from the very beginning. If 2.4 moles of sodium hydroxide, that's what I start with. 2.4 moles of sodium hydroxide. What in the world is sodium hydroxide? If you don't have a periodic table in front of you, that's okay. But sodium hydroxide is Na, which has a +1 charge. Hydroxide is OH with a -1 charge. If I'm going to put them together, +1, -1, I'm just going to put them together. NaOH. All right, so now we're going to set up a problem. Just like that. What unit goes down here at the bottom? The same as the top. Moles of NaOH. These are the same. Now let's keep reading. How many moles of sodium phosphate? So what is sodium phosphate? Let me help you out. Sodium is Na with a +1 charge. Phosphate is a polyatomic ion. Remember, we find that on the back of the periodic table. It's also in the formula at the top, but it's all right. PO4, -3. If I'm going to put them together, I need to cross those charges. So I'm going to get moles of Na3, because I crossed the charges, PO4. Now here I have a mole to mole. See that? I have mole at the bottom, mole at the top. Where am I going to get those numbers from? The balanced equation up here. What number is in front of NaOH? Let's find it. Here it is. 3. Let's put a 3 there. What number is in front of Na3PO4? There is no number, so it has to be a 1. What unit cancels out? Change colors real quick. Moles of NaOH, moles of NaOH. I'm left with moles of Na3PO4. If I multiply the top, divide by 3, I'm going to get 0.8 moles of Na3PO4. And there we are. There's our answer. Okay. And this will be where we start off on Monday.